Hello friends, welcome to our today's video lecture. In previous classes, we have studied about relation, what is relation, and we have also studied about various types of relation. Let us recall, we have discussed about empty relation, universal relation, and a pair of three relations which are reflexive relation, which are transitive relation, which are symmetric relation. You know what are these? A relation is said to be reflexive if each element of set A is related to itself. What is symmetric relation? A relation R is said to be symmetric relation if for elements A and B in set, if A is related to B, then B must be related with A. What is transitive relation? Transitive relation says if there are three elements in a set 1, 2, and 3. So if element A is related to B and element B is related to C, then it should conclude that element A is related to C. This is transitivity. And if a relation is reflexive, symmetric, and transitive, then such relation is called equivalence relation. We are clear with this. Okay. Now, in previous video, we were doing the exercise 1.1 of NCERT book, and we have completed till question number 5. So we will continue from the question number 5. So let's go. Now here you can see that the fifth question, check whether the relation R in relation R defined such that given and is reflexive, symmetric or transitive. We are supposed to check this relation is reflexive, symmetric or transitive. It is true or not. Now if you remember, this question is same as question number 2. In question number 2, the relation was given such that a comma b such that a is less than equal to b square, and in this relation the relation is given such that a comma b where a is less than equal to b cube. Very similar. You can do this question with the help of question number 2. So practice this at home. Let's go further. Now we will do next question, question number 6. What it says, let's read it. Show that the relation R in the set 1, 2, 3 given by R equals to 1, 2, 2, 1. This is the in tabular form. And he is asking that show that this relation is symmetric but neither reflexive nor transitive. So let's check. We know the conditions of these relations. Let's first check about the reflexive relation. In reflexive relation, we know that for what is the condition for reflexive relation? We know that if A, there is element in set A, its pair with itself 1, 1 must be in itself. If 2 is element of set, then 2, 2 must be in itself. But when you see in set 1, 2 and 2, 1, you will see that here in this relation 1, 1 is not there, 2, 2 is not there, and 3, 3 is also not there. So there we need only one contradictory example, and there are 3. So this is not reflexive. Now let's check for the symmetric relation. This relation is symmetric or not? And we know the condition for that. What are the condition? If A comma B is in relation, then B comma A must also be in the relation. So you will see that here 1 2 is in the relation, 1 2. So there 2 1 is also in this relation. So this relation for all A comma B, there exists B comma A in the relation. So hence we can say that this relation R is symmetric. I hope it is clear. Now let's go further. Transitive relation. What are transitive relation? First of all, let's see the condition. There are some students commented on our video that there is some confusion about the transitive relation. So first of all, let's clear that transitive relation. I am again repeating just think of the general term of transitivity. Transitivity says transfer of something. If let's suppose you have a chocolate and you give it to your friend. His name is Mohan, let's suppose. So my name is Kapil, and Kapil gave one chocolate to Mohan, and Mohan gave that chocolate to Ram. Now chocolate traveled from Kapil to Mohan and Mohan to Ram. Can you say that chocolate originally traveled from Kapil to Ram? We can eliminate this middle guy. If such relation is possible, so the transferring of chocolate is a transitive relation. There is transfer of something. If such relation is there, then such relations are called transitive relation. Let's take two examples. One which satisfies transitivity and the other which is not satisfying the transitivity. Now we will see that if I am saying, first of all, let's take example in general terms. So I am saying about brothers. All boys in your family are the set. Now if first boy is brother of second and second boy is brother of third, can you say first boy is brother of third? Just think of it. Think of any three brothers. Yes, you can say अगर पहला दूसरे का भाई है और दूसरा तीसरे का भाई है तो आप कह पाएंगे कि पहला तीसरे का भाई है. Now take a contradictory example. Now I am saying about friendship. You have three boys or girls, any three students. If first student is friend of second, okay, they are both all friends, and second boy is a friend of third, they both are friends. Now can you say first and third are friends? Is it necessary? No, it is not necessary. अगर यहाँ पर मैं बीच में आपको रख देता हूँ, अब आपका एक फ्रेंड है स्कूल वाला जिसके साथ आप स्कूल में पढ़ते हैं, और एक आपका फ्रेंड है दूसरा कोई ट्यूशन वाला. अब जरूरी है आपके सारे स्कूल वाले फ्रेंड्स आपके ट्यूशन वाले फ्रेंड्स के आपस में एक दूसरे के दोस्त हों? जरूरी नहीं है ना. सो फ्रेंडशिप इज नॉट अ ट्रांजिटिव रिलेशन. Now let's see this relation in terms of mathematics. If A is less than B, A छोटा है B से, and B is less than C, B छोटा है C से, can you say that A is less than C, A छोटा है C से? Just think of it. Yes, you can say if you take numbers, any numbers 1, 5, 1 is less than 5, then you take 5 is less than 10, 5 less than 10. Can you think about 1 and 10? Yes, 1 is less than 10. So this is a transitive relation. And similarly, you can see many other relations in mathematics which are not transitive. So this is the concept. One more thing I want to clear, I will talk about this question. Let's complete this, then we will discuss about something else. And now we are checking the transitivity. You will see 1, 2 is in the relation, 2, 1 in the relation. So 1, 1, first and third must also be related. It should be in the relation, but you will see that 1, 1 is not in the relation. So it is not satisfying the condition of transitivity. Hence, we will say that this relation is transitive on our given set of real numbers. Okay, I think this is clear. So this is not reflexive, this is symmetric, and this is not transitive. Now let's go for the question number 7. What it say? Let me read. Show that the relation R in the set A of all the books in a library of a college given by R such that x, y such that x and y have same number of pages is an equivalence relation. Two things. So first of all, imagine a library and there are many books, so many books, and this is our set. Now what relation he is defining? He is saying that x and y, two books are related if their number of pages, अगर इसमें 50 पेज है तो इसमें भी 50 पेजेस होने चाहिए, अगर इसमें 70 पेजेस है तो इसमें भी 70 पेजेस होने चाहिए. So two books will come in a pair of in relation if they have same number of pages. Okay, now let's see. Second thing, he is saying equivalence relation. What do we mean by equivalence relation? Equivalence relation means it should be reflexive, it should be symmetric, and it should be transitive. All three conditions should be satisfied. Now let's see. We will start with for this question. Let's make a book. Let's suppose we have a book, and here is the book. This is our book. Okay, now let's check for the reflexive. This is reflexive or not. Now think of a single book, because I have a book in my set, in my library. Uh, Book, I am representing it by B, because books start with B. Now number of pages in book B is equal to number of pages in book B itself. So I can make a pair B comma B is in R, hence R is reflexive. For any book you can say this कि अगर जिस बुक के अंदर जितने पेज हैं खुद के अंदर भी सेम नंबर ऑफ पेजेस है, तो each book have same number of pages as itself, so it is a reflexive relation. Okay, now let's check for symmetric relation. It is symmetric or not. uh, how will we check this? For this, I need two books. What is the definition of symmetry? If A is related to B, then B must be related with A. Okay, so I made here two books. One is of mathematics and second is of science. And I named them B1 and B2. Now, what is the definition? If B1, B2 belongs to R, I am supposing what it means, number of pages in book B1 equals to number of pages in book B2. Okay, now I can also write this number of pages in book B2 equals to number of pages in book B1, because they are equal. I can interchange their position, and what it means, B1 comma B2 belongs to R, hence R is symmetric relation. Okay, now let's check for transitivity. It is transitive relation or not. For transitivity we need three elements. Okay, so what I am doing, I will take three books. First book the same for mathematics, and I am taking the second book again of this science, and I will let's draw another book of, so because I need three books, and I made another book of English. Okay, I named this book B3. Now let's talk about these books. What is the condition? If B1, B2, B3 belongs to library, belongs to the set, okay, these three books. If B1, B2 belongs to R, B2, B3 belongs to R, then what should be true? B1, B3, first and third, these should be belongs to R. So number of pages in book B1 equal to number of pages in book B2. This is the meaning of B1, B2 belongs to R. क्या मतलब क्या है इसका? इसका मतलब है कि number of pages in book B1 is equal to number of pages in book B2 as defined in relation. And B2, B3 belongs to R. It means number of pages in book B2 equals to number of pages in book B3. Okay. Now using these two equations, you can see that number of pages in book B2 is common. So number of pages in book B1 will be equal to number of pages in book B3. Is it clear? It is very obvious. Okay, no? So hence we can say this is satisfying the condition of transitivity. Hence R is transitive. I hope this is clear. So this is transitive, symmetric, and reflexive. And we know that if a relation is reflexive, if a relation is symmetric, if a relation is transitive, the collection of all these relations, these three properties, I can say such relation is equivalence relation. Okay, so hence I have proved that this relation given by in question is equivalence relation. Okay, done. Now let's go further. Now let's do the next 8th question. What it says: show that the relation R in the set A given such that 1 to 5 given by R such that A minus B is even. मतलब उसके अंदर ऐसे पेयर्स आएंगे उनका डिफरेंस इज इवन, इज अ रिलेशन इक्विवेलेंस रिलेशन, मुझे प्रूव करना इक्विवेलेंस रिलेशन है. And show that all the elements of 1, 2, 1, 3, 5 are related to each other, and all the elements of 2, 4 are related to each other. है ना, 1, 3, 5 वाले भी खुद से रिलेटेड, 2, 4 वाले भी खुद से रिलेटेड, लेकिन 1, 3, 5 और 2, 4 वाले आपस में रिलेटेड नहीं है. So let's start. We will check for reflexive. This is reflexive or not. But before that, I want to clear one thing. All of us know that if you subtract even number from even number, you will get even number. Just think of any two even numbers, subtract them, you will get even number. Okay, very clear. And if you subtract an odd number from an odd number, what will you get? Think of any two odd numbers. Subtract them, what will you get? You will get an even number. Similarly, if you subtract an odd number from even number, what will you get? Just think of any even number, any odd number, subtract them. What will you get? Yes, you will get an odd number. And if you subtract an even number from an odd number, what will you get? You will get an odd number. So we will use these properties. Okay. Now start with you start with reflexive. It is reflexive or not. So let's go further. What is the condition? For all a belongs to a minus a is 0. Very clear ना? आप किसी भी नंबर से रिफ्लेक्सिव के लिए खुद से रिलेटेड होना चाहिए. a comma a belongs to r होना चाहिए. So a comma a belongs to r कब होगा? When a minus b is even. तो मुझे a minus b निकालना पड़ेगा. और a comma a के लिए मुझे a minus a निकालना पड़ेगा. So I found a minus a equals to 0 and 0 is an even number. Hence R is reflexive relation on my given set R. Done. Now let's check for symmetric. Here is the condition: if a is related to b, then b is related to a. Now I have a comma b related to R. So according to given relation, a minus b is even, and even number can be written in form of 2m. Okay, so I have written a minus b equals to 2m. Now I can subtract, multiply by minus, and b minus a equals to minus 2m. Okay, it is clear. Now I can also write b minus a equals to 2n, where m equals to minus n. I just removed the minus sign so that it can remain in form of an even number. Now b minus a is again even because it is in form of 2a. So I can write that b comma a also belongs to R. Now starting from a comma b belongs to R, it implies b comma a belongs to R. And what it means? Hence relation R is symmetric. We are done with the symmetry. Now let's check for the transitive. This relation is transitive or not. What is the condition? If a comma b belongs to R, b comma c belongs to R, then a comma c must belongs to R. The first element a and the third element c, they must be related with each other. Okay. Now a minus a comma b belongs to R. What it means? It means a minus b is 2m, even in form of 2m. Okay. 2, let's change it to divide it 2p, and b minus c is equals to 2q. I'm just writing 2p 2q that to show that these are even numbers. Now if you add two even numbers, what will you get? You will get again an even number. So I add both these equations. This will give me a minus b minus c equals to this, and b will cancel each other. So a minus c equals to 2 into p plus q, and I can write a minus c is even. Why? Because it is again a form of multiple of 2. 2 multiplied p plus q means it is an even number. So a minus c is even number. Hence a comma c belongs to R. This is satisfying the condition. Hence R is transitive relation. Now you will see that we have proved that this relation is this relation which we are discussing is what? This is this relation is we need to prove equivalence relation. So for this we have seen that this relation is symmetric, reflexive and transitive. So this is equal relation done. Now let's do the second part. Show that all the elements of 1, 3, 5 are related to each other. Now let's do this part. Now 1, 2, 3, 5, all these are odd numbers, and we know that difference between two odd numbers is even. You can check 1 minus 3, difference is 2. Difference between 3 and 5 is 2. Difference between 1 and 5 is 2. And the difference is all elements are related to each other because the difference is always even. Now the odd minus odd is equals to even. We know this. So for this set, this is true. Now for 2, 4, all elements are even, and we know that even minus even is equals to even. Difference of two even numbers is even. Hence this all the elements will be related to each other. Now here the next part says, but no element of 1, 3, 5 is related to any element of 2, 4. Why? Just think. 1, 3, 5 all are odd numbers and 2, 4 all are even numbers. What it means? It means I have to differentiate odd number and even number from each other. Even number from odd number or odd number from even number. I have to differentiate. And when we subtract an even number from an odd number, what will we get? We will get an odd number. So this is not satisfy the condition of relation, because relation तो कह रहा है कि उनका difference हमेशा even होना चाहिए, पर यहाँ पर we are getting the difference odd. Hence we can say that they are not related to each other. I hope it is clear. Okay. Now let's go. Now let's do the question number 9. What it says. Let me read it. Show that each of the relation are in the set A. Set A is all the integers x belongs to z such that x is between 0 and 12. 12 और 0 के बीच के सारे integers given by such that. दो हमें examples दिए हुए हैं और उसके बाद दो type दिए हैं सब parts, उन दोनों को हमें अलग करना है, relation दिए हैं. So for 9 the first part, if you can see that a comma b such that a minus b is multiple of 4. Is it similar to some question? In the question number 8, the last question, the relation was given that a minus b should be even, or I can say a minus b should be 2m. This can be written as multiple of 2. Okay, very done. And in question 9, what is he saying? He is saying that a minus b should be 4m, or I can say it should be multiple of 4. So in place of 2, you can replace number 4. They were multiple of 2 and this is multiple of 4. So both of these parts are very same. So you can do this at home. This is for your homework. Now let's do the second part. What it says? It says R is such that A comma B such that A equals to B. Condition क्या equal होनी चाहिए? Let's check for reflexive. Reflexive है या नहीं है? For all A equals to A. हर एलिमेंट खुद के इक्वल होता है, obviously common sense. It means A comma A belongs to R. Hence we can say this is reflexive. Now let's check for symmetric. This is symmetric or not? The condition, if A comma B belongs to R, what it means? A equals to B. You can also write B equals to A, and this implies B comma A belongs to R. So from A comma B belongs to R, I reached B comma A belongs to R. Condition of symmetry satisfied, and this is symmetric. Now let's check for transitivity. This relation is transitive or not. Okay. Now if A comma B belongs to R, B comma C belongs to R, this should imply A comma C belongs to R. This is the condition of transitivity. First element related to second, second related to third, then first should be related to third, A related to C. This should be in R. So let's write, if A comma B belongs to R, it means A equal to B. And if B comma C belongs to R, it means B equal to C. And with this, you can simply say that A is equal to C. Equality is transitive relation. भाई अगर पहला दूसरे एलिमेंट के इक्वल है और दूसरे वाला तीसरे एलिमेंट के इक्वल है, तो यू कैन से पहला और तीसरा भी आपस में इक्वल होंगे ना. दिस इज रिलेशन इज ट्रांजिटिव. वेरी क्लियर. ओके, नाउ लेट्स गो फर्दर एंड in this, what will we do? We will do now the, you will see that all this relation is equivalence relation. So all elements related to 1. इस क्वेश्चन में फिर एक और चीज पूछी इसने कि all the elements related to 1. 1 से कौन से elements related है. Now you will see कोई भी element B से related होगा. A related to B when A equals to B. And he is asking कि 1 से कौन से related है. तो only those elements will be related to 1 which are equal to 1. And which number is equal to 1? There is only one element. 1 is equal to itself. So all elements related to 1 is only 1. 1 is the only element which is related to itself according to this relation. Okay, done. Now what we will do? Now let's go further, and after this question, in this we will now do, we have done till question number 9. Okay, now let's do the go next. What we have in our hand, let's see. And you will see now we have question number 10. Let's start with. This question is quite interesting, and but he's asking, he's saying that give an example of a relation which is, and he gave some condition. उसने रिफ्लेक्सिव, सिमेट्रिक और ट्रांजिटिव में से कुछ कंडीशंस दी हैं कि भाई ये दोनों है, ये वाला नहीं है, ये दोनों है, ये वाला नहीं है. तो with those condition we have to give examples, है ना. You can try your examples, and we will take an example from real life, and we will take another example from mathematics. Okay, so let's start. You will see that here for first, what is the condition? He's saying relation should be symmetric but neither reflexive nor transitive. आपको ऐसा relation बताना जो symmetric हो पर reflexive ना हो, transitive भी ना हो. Okay, so let's draw one relation. I'm taking a equals to 1, 2, 3, you know, and let's draw a relation. Now we will see, because this relation is symmetric, so if 1, 2 is in it, 2, 1 must be in it. I have to write it in this way. Now just think about this relation. If this is relation I have given, and 1, 2 is in this, 2, 1 is there. For a, b, b, is there, so this is symmetric. Done. For reflexive there must be 1, 1, 2, 2 and 3, 3. But I don't have written any of them, so I intentionally don't write them because I don't want this relation to be reflexive. Hence this relation is not reflexive. Now let's check the symmetry. Now let's check the transitivity. This relation is transitive or not. You will see for transitivity a, b is there and b, c is there, then first element should be related to third. It means 1 related to 2, 2 related to 1, then 1 should be related with 1. So that's why I don't have written 1, 1 in this relation. So this relation is also not transitive. Now let's take an example from real life. I am defining a set A, and set A says student in class 12. All students in class 12. And I have a person. And now I am defining relation friendship. Relation is friendship. Now can you say I am friend of myself? No. So this person is not related to itself. So this relation is not reflexive of friendship. Relation of friendship. Now we will talk about symmetric. For symmetric I need 2 persons. So I draw 2 boys in your class. Now if red one is friend of yellow, then yellow is friend of red. If A is related to B, then B is related to A. So this relation is symmetric. Now we need transitivity. For transitivity, we need 3 persons. And in this, we will check the condition. Now you will see that if blue is friend of yellow and yellow is friend of red, then it is not necessary that yellow is friend of red. है ना? तो ये ट्रांजिटिव नहीं, इसको जरा ध्यान से समझिए. हो सकता है कि जो येलो वाला है जो और येलो और ब्लू है वो दोनों आपस में फ्रेंड हो, है ना, दे प्ले टुगेदर, वो दोनों एक साथ खेलते हैं गेम्स ग्राउंड में. एंड येलो एंड रेड आर आल्सो फ्रेंड्स बिकॉज दे गो टू सेम ट्यूशन. नाउ इट इज नॉट necessary that blue and red they are friends. Is it necessary? Just think of it. Give 2 minutes to yourself and think, is it necessary that they are friends? There are many examples you will see in your life, in your class, that they are not friends. This is the case. So this relation is not transitive, and this is satisfying the condition that this is symmetric but neither reflexive nor transitive. Okay, now let's go further and let's do the second part of this question. What it says, it is saying give a relation which is transitive but neither reflexive nor symmetric. So I am giving a relation which is transitive, neither reflexive nor symmetric. So let's try this. Again I am giving the same set 1, 2, 3, and my relation is 1, 2, 2, 3. So 1, 3 must be there. Now see this carefully. Because I need this transitive. So if I have related 1, 2, and 2,3, तो पहले वाला और तीसरे वाला should be related for transitivity, and I want a relation which is transitive. That's why I added a pair 1,3 in it so that it became transitive. Now I don't want it to be reflexive, so you can leave any of the element 1,1, 2,2, 3,3. For reflexive, there must be all pairs for all set, for all elements of set. If you leave any single pair 1,1 or 1,2 or 1,3, it will not be reflexive. I left three of them. Okay. Now for symmetry, if 1,2 is there, then 2,1 must be there. But you will see it is not there. For 2,3, 3,2 must be there, but I left that. For 1,3, 3,1 must be there, but I left that. If a single element is left without its symmetric part, then you can say this is not symmetric. Now, this is our mathematical example. Now let's do a example from a real life. Okay. And I have an example for this, an interesting one. Just see that I'm giving a set as all students in your class. In your class 12, all students are in my set. I am defining this set, and these are my relations. Okay. Now, my relation is A is taller than B. Okay, relation is my A is taller than B. One should be taller than second, then I will say they are related to each other. Now, can you say I am taller than myself? No. No one is taller than himself or herself. So this relation A is taller than B can't be satisfied for a person with itself. You are not related to himself. So this relation is because their height are equal. So they are not reflexive. Now for symmetry, when you 2% height on another, now you will see that the first person A is taller than B. So they are related. Can you say B is taller than A? No, he is shorter than A. तो छोटा है ना उससे. So this relation is not symmetric. Now for transitivity, I need 3 students. I don't one more C. Now can you say if A is taller than B, B is taller than C, can you say A is taller than C? Yes, obviously. And so this relation is transitive, and we have satisfied the condition asked in our question. Now let's go for the third one. What he is asking? He is saying we have 3 type of relation: reflexive, symmetric, and transitive. And give an example to me which is reflexive, symmetric, but not transitive. है ना, ऐसा एग्जाम्पल बताओ जो रिफ्लेक्सिव और सिमेट्रिक हो, but transitive. Now for mathematical relation, I am defining 1, 2, 3, and relation is 1, 1, 2, 2, 3, 3. Now see this, because he is saying it must be reflexive, so there must be pair with itself of all elements. 1, 1, it is there. 2 is the 2, 2 must be there. 3 is there, then 3, 3 must be there. For reflexive, to satisfying the condition of reflexivity, I added all these pairs. Now for symmetry, if I added 1, 2, I added 2, 1 with itself, so that symmetry maintains. Now if 2, 3 is there, I added 3, 2. But now you will see 1, 2 is there, 2, 3 is there. So 1, 3 must be there. For which? For transitivity, है ना. और मुझे ऐसा रिलेशन चाहिए जो ट्रांजिटिव ना हो. सो मैंने क्या किया, मैंने I left this from my set. I completed my relation, and you will see this relation is reflexive because all are there. This relation is symmetric, but this relation is not transitive. Okay, done. Now I'll ask you to this question, the real life based part of this question. This is I'm defining the set and set of all neighbors, है ना. आपके सारे पड़ोसियों को हमने एक सेट में ले लिया, and I am defining a relation A lives within 1 kilometer of B. एक जहां पर रहता है उसके 1 किलोमीटर के अंदर अंदर मेरा जो है सेकंड वाला जो है वो B रहता है, इन 1 किलोमीटर रेडियस. ना, ये रिलेशन है मेरा। सो मैंने ए का घर बनाया, 1 किलोमीटर की रेडियस बनाई, एंड बी लिव्स देयर, आई ड्रॉन अनदर guy, another person who lives in this 1 kilometer radius, and I draw the house B of B. This is B, and B lives in 1 kilometer radius. Okay, so A and B are related. Done. Okay. Now you will see that if we check for reflexivity, A lives within 1 kilometer radius of his house, है ना? So A is related to itself within 1 kilometer. तो 1 किलोमीटर के अंदर ही तो रहता है, तो वो related हुआ. Now if you say A lives in 1 kilometer radius of B, then you can also say B lives in 1 kilometer radius of, okay, देखो 1 kilometer radius करोगे तो वो उसके अंदर आ जाएगा. So this relation is symmetric. Now I drawn for transitivity a third person who is C. Now B and C lives in 1 kilometer radius. Now you will see A lives in B 1 kilometer radius of B, and B lives in 1 kilometer radius of C. So A related to B and B related to C, but A don't live in 1 kilometer radius of C, hence A is not related to C. पहले वाला दूसरे से रिलेटेड है, A B, B और C आपस में रिलेटेड है, लेकिन पहले वाला और तीसरे वाला फर्स्ट एंड थर्ड आर not related to each other. That's why this relation is not transitive, and we satisfied our conditions. Okay, I hope I am clear. Now there some of you can say that कि सर ऐसा हो सकता है कि वो रहने लग जाए, क्या पता वो रहता हो, है ना? तो अब ऐसा होगा कि नहीं होगा, है ना? तो उसके लिए हम क्या करेंगे कि हमारे पास में जो है उसको हम ध्यान रखेंगे कि ट्रांजिटिविटी का मतलब है कि हर बार होना चाहिए. मे और मे नॉट condition is not applicable in transitivity. All the pairs should satisfy that in all cases. Then we will say only that this is transitive relation. Okay, so let's go further. Reflexive होना चाहिए, symmetric ना हो, and it must be transitive. So I defined a set 1 to 3, and I have given a relation 1, 1, 2, 2, 3, 2, because this is reflexive. Now for transitivity I made a pair 1, 2, 2, 3 and 1, 3, है ना? 1 related 2 से, 2 related 3 से, तो 1 related होना चाहिए 3 से. So I added 1, 3 because I wanted this to be transitive, but I wanted a relation which is not symmetric. So for 1, 2 there must be 2, 1 if it is symmetric. That's why I left 2, 1 so that it don't become symmetric. And you can say this is reflexive, transitive, and just it is not symmetric. So you can see this because the symmetric pairs of 1, 2, 2, 1 is not here. Symmetric pair of 2, 3, 3, 2 is not here, and symmetric pair of 1, 3, 3, 1 is not here. Hence I can say this relation is not symmetric. Now the real life part I give this is as homework. Now search and you can tell in comments which is the relation satisfying this. Now let's go further. Now I am supposed to give an example which is reflexive, symmetric, but not transitive. So I have given a set 1, 2, 3 and relation 1, 2, 2, 1 and 1, 1, and because I don't want it this reflexive, so I left. Now we will see 1, 1 is there, 2, 2 is there, but only one pair 3, 3 is not there. That's why this is not reflexive. Only one contradictory condition is sufficient to remove the condition of reflexiveness. Now this is symmetry because 1, 2 is there, 2, 1 is there, and this is transitive because 1 related to 2, 2 related to 1. तो पहले वाला तीसरे वाले से related होना चाहिए. मेरे पास 1, 1 है. And you can also say in this that 2 related to 1, 1 related to 1, तो पहले वाला तीसरे से 2, 1 होना चाहिए. And 3, 3 is not here, so this is not reflexive. I hope this is clear. Now I am giving a real life example for this. Set of all girls in a family, है ना? एक family के अंदर सारी girls उनको हमने एक set में रखा. Now what I am doing, मैं girls बना देता हूँ. ये हो गई हमारे पास पहली girl, ये हमारे पास है ना itself. अब relation क्या है मेरा? Sister. If A is sister of B, okay ना? Relation मैंने define किया sister का. अब क्या कोई गर्ल कह सकती है आई एम सिस्टर ऑफ माई सेल्फ? No, a girl can't say I am sister of myself. So any girl of a family is not related to itself, herself. A girl is not related to herself. That's why this relation of being sister is not reflexive in our case. Not sister of herself. है ना? So this relation is not reflexive. Done. Now for symmetry, I need two girls. So I will draw a second girl. So red and girl and green. So if red is sister of green girl, then green must be sister of red. Remember, I am defining all the girls in my set, so there can't be any boy. So if red is sister of green, then green must be sister of red. So this relation is symmetric. Okay, done. Now for a transitive, I need third girl, red, green, and blue. Now if red is sister of green and green is sister of blue, can you say that red is sister of blue? Just think of yes, of course, क्योंकि एक ही फैमिली में है और गर्ल्स है सब, so I can say कि भाई फर्स्ट थर्ड की सिस्टर है, सेकंड थर्ड की सिस्टर है, तो पहली और थर्ड भी आपस में सिस्टर्स होंगी. So I can say that this relation is transitive, है ना? I hope this is clear to you all. Okay, now these are the 5 parts. Now let's go for the third.